Hey, how's it going, everyone? So in this video, I'm going to go over section 1.2 from the textbook. We're going to be looking at segments and the segment addition postulate. Right. So in the first three exercises, we're going to plot some points. All right. So this kind of harkens back to algebra, where we're plotting coordinates in the coordinate plane. Okay. And then we're going to determine whether the segment AB and the segment CD are congruent. Okay. So if you've read this section, then you would know that congruent segments have the same length. Okay, so let's write that down. Okay, congruent means the same length. All right, so let's take a look at problem number one. All right, so let me go ahead and draw in an x-axis and a y-axis. So that's x and that's y. Okay, so our first point is at -5, +5, and then -2, +5. All right, so that's the segment AB. And then we have point C is at 2, -4, and then D is at -1, -4. Okay, so that's segment CD. All right, now since these are horizontal segments, finding their length is pretty simple. You're just going to count the number of grids here, right? So segment AB is 3 units long. Segment CD is also 3 units long. So these two segments are congruent. They have the same length. Okay, so I'm just going to put, I'll put a C here for congruent. All right, let's take a look at question 2. We'll set it up the same way. Draw in X and Y axes. Okay. All right, so 4, 0 is point A. 4, 3 is point B. And then -4, -4 is point C. -4, +1 is point D. Okay. All right. Now these segments are both vertical, and just like horizontal, you can just count the number of grids to figure out how long they are. So segment AB is 3 units long. Segment CD appears to be 5 units long. Okay. So these are not congruent. Okay. They have different lengths. All right. Finally, question 3. Can't forget to draw our axes first. Okay, so X and Y. Okay. So point A is at -1, 5. Point B is at 5, 5. Okay. So that's our first segment. C is at 1, 3. And D is at 1, -3. Okay, so C, D. Okay. All right, so now we have a combination of horizontal and vertical segments, but still the same concept applies. You can just count the number of grids. Okay, so from A to B, that's 1, 2, 3, 4, 5, 6 grids, so it's 6 units long. From point C to D, that's 1, 2, 3, 4, 5, 6 units long as well. All right, since both segments are the same length, we call them congruent. All right, so now I'm going to transition to these segments, which aren't in a coordinate plane. They're just drawn and labeled, okay? And we need to find the distance between point V and W, right? The length of this segment here. So VW, let's find that length. VW, let's find that length. And VW, let's find that length. Okay. So the segment addition postulate says that the parts should add up to the whole, right? So the left part here, let me color code. Right. So that segment there from V to W plus that segment there from W to U should add up to the whole length of the segment. Okay. And so we could write it using letters first, right? VW, right, the blue portion, plus WU, the yellow portion, will equal VU, the entire portion, okay? So the parts add up to the whole. Okay. So VW, we don't know, so we'll just write VW. WU is 8, so we can substitute 8. VU, the entire distance, is 31, so we would substitute 31. Okay. And then we can subtract 8 from both sides. Okay, so what I'm doing is I'm treating VW like a variable. Like in algebra, this might be x plus 8 equals 31. I'm just using 2 letters instead of 1 letter as a variable. Okay. So VW, the length of that blue segment, is going to equal, what, 23? Yeah. Right. All right, let's do that again in problem 5. So I'll just color code the portions of that segment. So we've got the UV segment and the VW segment. Okay. So we can write UV plus VW equals UW, right? The portion on the left plus the portion on the right equals the whole thing, right? The parts add up to the whole. All right, now let's substitute the lengths that we know. The length of UV is 6. The length of VW is unknown. The length of UW is 18. Subtract 6 from both sides, and we find that VW is equal to 12. All right, and then we'll do this one last time. Okay, just color code each part of the segment. So blue and yellow, right? Patriot Pride. All right, so we can write the blue segment, WU, plus the gold segment, UV, equals the entire segment, which is WV. And so WU is 45, UV is 30, so WV, or VW, remember the order that you name a segment doesn't matter, we can call it VW or WV. All right, so we're just gonna add these two together, and that adds up to 75. So 75 equals the distance from point W to point V. All right, so really this is just like, you know, addition in a geometry setting, right? Or subtraction, right? We're doing subtraction here. All right, number 7. A bookstore and a movie theater are 6 kilometers apart along the same street. Okay, so let's draw a street. And we'll place the bookstore here, we'll call it B. And we can place the movie theater here, call it M. And then we can mark that distance as 6. Okay. A florist is located between the bookstore and the theater on the same street. The florist is 2.5 kilometers from the theater. Okay, so let's call this T for theater instead of M. Okay, so from the bookstore to the theater, 6, and then there's a florist, which we'll call F, whose distance is 2.5 kilometers. I should probably put the units, km, 2.5 kilometers from the theater. Okay, so now the question is, how far is the florist from the bookstore, right? FB, we want to figure out the length of that segment. All right, so let's write BF plus FT, right? The two small parts need to add up to the whole part, okay? And the whole part would be BT, right? That's the entire segment. Okay, so BF we don't know. FT is 2.5. BT is 6. All right, so we'll subtract 2.5 from both sides. And we get the distance from B to F, the bookstore to the florist, is equal to 3.5. And then we need to include context, right? This problem we know units, so we'll put km for kilometers. Right. And you can always just verify, right? 3.5 plus 2.5 should add up to 6.